All right, guys, good morning. We are starting the Magic X. This is the beginning of lesson 5.3. So 5.3 is on factoring and factoring by solving. So in order to factor and factor effectively, we have a few tricks and techniques we can utilize in order to make that method the most effective. So today we're going to look at the Magic X and GCF. Monday we're going to look at difference of squares. Tuesday we're going to look at special formulas. On Wednesday we're going to do the application of all of these methods. Thursday we'll do grouping. Friday we'll do A values equal 1. And then the following week we'll do A values greater than 1. So we're going to work through all those different methods. Then we'll solve by factoring. So we previously solved by graphing. So the whole point of factoring is to get our solutions. So now that we know what solutions look like graphically, we're going to see solutions algebraically. And then we're going to look at functions that cannot be solved by factoring and talk about other techniques. So the Magic X is a method in which we are going to create a product sum duo. So what I'll have you do is you will draw, and I believe yours are circles on your page because I couldn't do the images like this. But you're going to draw an X once we do this on papers on our own. And the numbers on the side are going to represent the product of the number up top. And then the two numbers on the side will represent the sum of the bottom below. So all four combinations of numbers are going to be products and sums of the numbers on the sides. So for example, my side numbers are -3 and +9. The product of those two numbers is -27, and the sum is 6. More of the cases we're going to be looking at is being given the product and finding the sum. So in factoring, you multiply the first and the last term, and that gives you the product. And you look at the middle term, and that gives you the sum. So when we factor, you'll hear me say the factors of 12 that sum to 7. So I need two numbers that multiply to 12 and add to 7, which in this case are +3 and +4. Two numbers that multiply to -18 and add to -7. So the only way to get a negative on top is to have a negative factor and a positive factor. And in this case, a -9 and a +2 will give you -18 and -7. So here we have an example where we're given the top number and one of the factors. So if I have -30, I need a number that multiplies by 2 to -30. So -15. A negative times a positive is a negative. And then you add them together to get the bottom. So -15 plus 2 is -13. We have -10 and positive 3. So a negative up top and a positive down below is a negative and a positive. And in this case, the negative is the smaller of the numbers since their sums are positive. So you have 5 and 2, where the 2 is negative and the 5 is positive. 24 and negative 10. So once again, you need a number that multiplies to 24, but sums to negative 10. So if I have a positive up top and a negative sum, then both my factors are negative. So our lesson is not just on the magic X. We're also going to go back and reference the word GCF. So what is a GCF? A GCF is the greatest common factor. So I just use the word factor a lot with our magic X's. Factors are numbers that multiply to give you that number. So the greatest common factor is the largest multiple that can divide into that number. So what is a greatest common factor? It is the largest multiple of a set of numbers. A technique that we use is factoring. Factoring is the rewriting of an expression as a product of its factors. And again, here's the formal definition of greatest common factor, which is a common factor of the terms of the expression. This must be the greatest coefficient, and something I left out is that it is also the greatest exponent of the variable. So if you have a set of variables like x cubed, x squared, and x, then the GCF would be x because each term at least has an x in it. So variables also come out with us on our GCFs. There will be factoring equations where you have to pull out a variable in order to be able to factor it the rest of the way down. When we get to the technique of grouping, you must know how to find a GCF because it's the only way to factor by grouping. So that is why we do a little review on GCF today. So if we have 6x plus 18, the GCF is the largest number and variable combination. So in this case, both of those divide by 6. So we're going to factor out that 6, and that leaves behind x plus 3. So you should be able to use the distributive property to get back to what you started with for all of the GCF problems. So the distributive property acts as a guess and check sort of technique in which you can multiply back in and simplify. 9x minus 81. So again, 9x and 81 both divide by 9. Factoring out the GCF. And again, doing a quick check, 9x times 9 is 9x, 9 times 9 is 81. X to the fourth and x squared. So no coefficients. All we're looking at is our variables. So they both contain at minimum 2 x's. So we know that we can bring out an x squared.
And then that leaves behind x squared. If you take all of the x squareds away from x squared, you need that placeholder of a 1. So that if I were to distribute that back in, there's something holding its place. So you put in a 1 if you take away all of the variables and coefficients. Now we have a GCF that takes out both a variable and a coefficient. So both 5 and 15 divide by 5, x cubed and x, so they both contain an x. So my GCF is 5x, and that leaves behind x squared plus 3. And again, you can always quickly distribute back in your head 5x cubed, 15x. Okay, so today's lesson is pretty short and sweet because I want to make sure you're sufficient with doing the magic X's and the GCFs. You do, for that reason, have a decent amount of practice problems for homework. And again, there is a spot on Fusion for that Dropbox of this assignment. On Monday, we're going to pick up with actual factoring and looking at our special formulas. So we'll get difference of squares and we'll look at perfect square trinomials, etc. So you're doing the 5-3 Magic X handout and the 5-3 GCF homework handout. They should be the next page in your notes packet.